Dear students, you are welcome in this class. Today is 31st March 2026, and in this exercise, we are going to understand how to compute the seed rate for rice nursery. Yesterday, we discussed in length about different methods of raising rice nursery. Those methods were wet bed method, dry bed method, Depot method, modified mat nursery, and bubble tray method. There were 5 methods of growing rice nurseries. And you have also seen that method. For different methods, the seed rates were different. Generally, in case of method and dry bed method, seed rates are quite high compared to your SRI method, method, modified MET method, etc. So seed rate is requirement of seed is also affected by kind of nursery we are going to grow. Number two is estimation of crop yield. We will estimate the crop yield. So this does not apply just to rice. You can extend this concept to other cereal crops like wheat, barley, oats, maize, etc. So same can be extended to others also. So estimation of crop yield based upon certain yield attributes. What are the yield attributes that are more important in deciding the crop yield? So we will know different components and their influence on grain yield. So you will get some numericals on this. And the third part of this exercise is computation of grain yield efficiency index. So anybody having idea about grain yield efficiency index? Anybody has any idea about this index? All right. So what happens when we grow different varieties or different genotypes of different crops? Some can efficiently utilize a particular nutrient and some cannot utilize that much efficiently. So to identify nutrient efficient cultivars or nutrient efficient varieties, we need to compute grain yield efficiency index. Certain cultivars may use phosphorus in a much better way than the other cultivars. Similarly, certain cultivars or varieties can utilize or utilize nitrogen more efficiently than other cultivars. So this grain yield efficiency index can be worked out for individual nutrient. It cannot be worked out for 2, 3, 4 together. We need to identify efficient cultivars for different nutrients differently. Nitrogen use efficient cultivars, zinc use efficient cultivars like that. So you will see how we can compute grain yield efficiency index, and we can divide cultivars or varieties into whether they are efficient, moderately efficient, or they are inefficient. There are 3 classes for nutrient efficiency of different cultivars or varieties, or you can call them genotypes. So this is what we are going to discuss today. So let us start with computation of seed rate. So you have seen yesterday that there are two methods of growing rice or establishing rice. One is direct seeded, other is transplanted method. So you know in transplanted rice, we need to grow some seedling in the nursery area. And these seedlings are definitely raised in nursery. And there are a number of methods that we have discussed yesterday. You can see point number 3, like wet bed method, dry seeding or bed method, depot method, and modified mat nursery method. So modified mat method. So these methods have been discussed yesterday at length. The nursery area for transplanting of 1 hectare land would depend upon the method of raising nursery. For example, you have seen in case of dry, dry bed nursery, the area requirement was more than the wet bed nursery method. And in case of SRI method, the requirement was 100 meters square. Similarly, in case of other method like depot method, the area requirement was somewhere around 60 to 75 meters square. So depends. So what should be the optimum seed rate to be used for preparation of nursery for 1 hectare transplanting. Whatever method we are using, method of raising nursery we are using, we need to find out the optimum seed rate for different methods or optimum seed rate required under different methods of raising rice nursery. So seed rate in wet method of nursery, how to calculate, or there are some recommendations you are seeing on the slide. For example, it was told to you yesterday, fine seeded varieties, their seed requirement is 20 to 25 kg per hectare. If you have medium seeded varieties, 25 to 30 kg per hectare. Bold seeded varieties 30 to 35 kg per hectare. So more seed requirement as the size of the seed increases. For hybrids 18 to 20 kg per hectare. So higher the seed rate, more nursery area is required. Seed rate or nursery area would also vary with, means the seed rate as well as nursery area will vary with variety. Test weight means more test weight means less seed. Less seed means you need more seed actually. And plant spacing. Narrower the spacing, seed requirement is more. Number of seedlings to be transplanted per hill. Many times farmers are transplanting 2 to 3 seedlings, but if they transplant just one seedling, the seed requirement will be different. But farmers like to have 4 seedlings per hill, then the seed requirement will be different or more. So number of seedlings also decide that what will be the seed rate for rice. So seed germination also. After the number of seedlings, we go for seed germination. If seed germination is low, then we need more seed rate. And also after germination, what happens? It is called as field emergence. Field emergence means the seedling will come out from the soil. That is seed emergence. So not all germinated seed will come out from the soil. The field emergence, and you can also call it seed emergence, is not 100%. It may be low. So there we need to make adjustment for these two also, for germination percentage as well as seed emergence or field emergence percentage. Is it clear to you, Ritik?
Yes, sir.
Is it
Yes,
okay?
sir.
Good.
Yes, sir.
Any point you are getting it? So these are the factors that will decide ultimately the seed rate. Now, how to calculate? We know that area to be transplanted is, suppose, 1 hectare, 100 meter into 100 meter, 10,000 meter square area is to be transplanted. Then how many hills per hectare we require at a spacing of 20 by 20 centimeter or 20 centimeter by 20 centimeter spacing. So here important point is that we need to find out the number of hills. Number of hills you understand? In case of rice, hills means the place where you are transplanting a seedling, one seedling or two seedling or three seedling at one particular point in the field. You transplant, and then the height of this plant is more than the soil. It is above the soil. So it looks like a hill. Therefore, name comes hill. Hill is a place, or when you have a spacing from row to row and from plant to plant. And then there is one place which will have same spacing in the row and same spacing within the row. So that particular place where seedlings are transplanted is called as a hill. So hill, you can have initially 2 seedling, 3 seedling, and then it can give tillers. And those tillers will also be called as a hill. And at one hill, normally you can find 8 to 12 tillers. 8 to 12 tillers per hill are there in normal varieties of rice. Now question comes, if we know the spacing, 20 centimeter by 20 centimeter, can we work out the number of hills? So this is actually, you can say in other words, like if you have wheat crop, if you have maize crop, if you know the spacing, within the row and between the rows, can you work out the plant population? Anand?
Yes, sir. Yes.
Yeah, how to do it?
Sir, area upon spacing.
Good. Area upon spacing. So the unit of both has to be same. Either it has to be in meters or it has to be in centimeter. If area you are taking in meter square, then the spacing should also be converted into meter square. Suppose it is 20 centimeter by 20 centimeter, then it will be zero point 0.2 meter into zero point 0.2 meter. Then it will be 2 to 4, 0.04 meter square, isn't it? So if you divide the 10,000 by zero point 0.04, then you will get the number of hills per hectare. Is that correct?
Yes, sir. Number of hills have.
Yeah. Other way is that you can do it for just for 1 meter square area. You can do it for 1 meter square area, and you can convert it into centimeter also. 100 centimeter into 100 centimeter is 1 meter square, and divide by the spacing 20 by 20. So 100 into 100 divided by 20 into 20. So it will give you the number of hills per hectare. Similarly, you can calculate the number of seeds that will be required in maize or wheat crop if you know the inter and intra row spacings. Now it can be calculated like this: 10,000 is 100 meter into 100 meter, divide by zero point 0.2 into 2, zero point 0.2, and it is worked out to be 2,50,000 hills per hectare, or 2.5 lakh hills per hectare. So many hills we need to have in 1 hectare. That means if we plant one seedling at one place, then at least 2.5 lakh seed will be needed. And if we have two seedlings in one place, then it will be 5 lakhs, and so on. If you need three seedlings, then you multiply 250,000 by 3 to get the required number of seeds. I hope you understand it. Now, next is how many seedlings per hectare? If you have four per hill in one place, you are transplanting four seedlings. Then how many seeds will be required, or how many seedlings will be required? Then you can see this 2,50,000 multiplied by 4. So you get 10 lakhs. So 10 lakhs is the answer in this case. So many seedlings are required. Now question comes, that can the same number of seeds produce the same number of seedlings? Suppose you have 10 lakh seedlings are required. So if we take 10 lakh seed of rice, can 10 lakh seed of rice give us 10 lakh seedling? No, they cannot give, because some of the seed will not germinate, and some of the seedlings even they are ready, they are germinated, but still some seedlings may die. Mortality can happen in the seedlings. So then we need to increase the seed rate to adjust the germination as well as the mortality percentage. So now, in the last case, you have seen we require 10 lakh seedlings. So that means you need 10 lakh seeds per hectare. Now we can calculate what is the weight of 1,000 seeds. Suppose right now we are not adjusting for the germination and mortality. We can adjust it later. So right now, suppose we have 10 lakh seeds per hectare. Then we need to know the 1,000 seed weight. If we know the 1,000 seed weight, which normally ranges between 20 to 30 in case of rice, and this is the weight of paddy, coarse rice or rough rice. So if we take mean as 25 gram, 1,000 seed weight is 25 gram. So I can easily calculate weight of one seed. 1,000 seed have 25 gram. So one seed will have 0.025 gram of weight. And then I can multiply that with the 10 lakh. And then I can get the seed rate. So how much seed needed to plant 1 hectare? We can work it out. So 10 lakhs were the requirement of the seed into 25 gram. 25 gram divided by 1,000. It will come out to be 0.025. and multiplied by 10 lakh, you get 25,000 gram. Remember, the unit is in gram. Now we need to convert it into kilogram by dividing with 1,000. Now, we need to adjust for the germination because you will never find 100% germination. Then we need to increase the seed rate. So in the last slide, we have seen it was 25 kg. So 25 kg seed can make 10 lakh seedlings if there is 100% germination and there is 0% mortality or death of the seedlings. But that does not happen under practical conditions. So suppose we need to know the germination percentage. Every seed bag will have germination percentage. So here, normally the germination percentage in rice can be 50 to 90%. It is just a range. Consider this is hypothetical example, not the real example. So in this case, we assume that germination is 70%. So everybody knows what is meant by germination. Germination is just breaking of dormancy and the young baby which is sitting inside the seed get awakened, get activated, and it starts growing. That is your seed germination. Seed germination. So now at 70% germination, how much seed needed per hectare? How much seed needed per hectare? So now we need to adjust this. So instead way, we can divide this by 70%, 25 divided by 70%, or you can say it is zero point 0.7. So zero point 0.7 is 70%. So 25 was the seed rate and divide by 0.7, you get 36 kg. So here the 30% deficit in germination can be compensated by increasing the seed rate. So now it is 36 kg. So what percentage of seedlings survive in wet nursery? So seedlings have emerged, they are there, but they can still die. Germination can happen, and after germination, some can remain inside the soil also. Some may not come out of the soil, some may come out from the soil, but they can die immediately. So death of the seedlings will be there. So what percentage of seedlings survive in wet nursery? So assume the range is 50 to 90% and take the average value as 70%. Suppose 70% seedlings can survive. Then again, we need to adjust like we have adjusted above. So in this, finally, how much seed needed to plant 1 hectare? So both these adjustment can be made over 25 kg. Over 25 kg. 25 divided by 70% for germination percent and 70% for survival rate, 70%. So 70% means zero point 0.7 and zero point 0.7. So it comes out to be 51 kg per hectare. So this is how we can calculate the seed rate. Any problem to anybody, any question, any doubt?
No, sir.
Clear? Now, calculate seed rate of, this is a numerical. I am showing you how to solve it. So it is same what we have done right now. So here what is given to us is plant spacing is given 20 centimeter by 10 centimeter. 2 seedlings per hill are to be planted or transplanted. In one place, 2 seedlings, 1,000 seed weight is given 30 gram, and then seed germination is 90% and seedling survival is 80%. So calculate the seed rate of rice needed to transplant 1 hectare area based upon the following information for wet bed nursery. Question is clear to you? It is again given here. So now, first of all, we need to calculate how many hills will be there. Like in last example, we have seen. So number of hills is equal to, as I told you, instead of meter, we can take centimeters. So 100 centimeter into 100 centimeter. This is the area of the field where we want to transplant rice. So this is equal to 1 meter square. Divide by the spacing. Spacing given is 20 centimeter into 10 centimeter, and you can get 50. So there will be 50 hills. If you have a spacing of 20 centimeter by 10 centimeter, there will be 50 hills. All the students must be cautious in your interviews, in your exams. Such simple questions are asked. Suppose spacing is 25 by 10, then calculation is very easy. So you can work it out uh, within seconds. So remember this, these kind of calculations are important and they are applicable to all other crops also. Now, so it was the case of 1 meter square. In 1 meter square, we had 50 hills. So that means in 1 hectare, how many hills will be there? Because 1 hectare is 10,000 meter square. And we know about 1 meter square has 50. So number of hills per hectare is equal to 50 into 10,000. It comes out to be 5 lakhs. So 5 lakh seedlings are required if you transplant one seedling in one place for transplanting 1 hectare area at a spacing of 20 centimeter by 10 centimeter. So now number of seed to get 5 lakh seedlings. Seedlings required for 1 hectare because at one place we are transplanting two seedlings. We are transplanting two seedlings. Then it will be 10 to the power 6 or it become your 5 lakh become your 10 lakhs. Is it okay? 10 lakhs. Now, weight of one seed. We want to know what will be the weight of 10 to the power seeds actually. 10 to the power seeds because there are number of seedling and number of seed are equal here. Assuming it has got 100% germination and 100% survival. Now we need to know what will be the weight of 10 to the power 6 seeds. So in this case, we know the 1000 seed weight is 30 gram. So weight of one seed will be 0.03 gram. You can divide 30 by 1000 gram. So it comes out to be 0.03 gram. So weight of 10 to the power 6 or 10 lakh seed will be 10 to the power 6 into 0.03 gram. And then you can multiply it and solve it. It comes out to be 30 kg. So you can see it is 30 kg. Now we need to adjust for the germination as well as survival, as we have seen in the last case. So seed germination is 90%. And please keep pen, pen and paper with you. I will give you homework. Okay. So seed germination is 90%. So you can adjust straight way also. 25 or 30 kg was the seed rate. 30 divided by 0.9. So you will get it. So, but that we are not going to do. Here you can know it. You can do it mechanically also this way. So if 90 kg seed germinate, seed requirement is 100 kg because germination is 90%. Suppose 1 kg seed germinate, then the seed requirement will be 100 by 90. Means you need more seed because germination is 90%. Then if 30 kg, so I stop here and now we can join the link 3, sorry. We can join the link number 3. I stop here and all can join. First I will join and then you can also join the link. I So you can see that if 90 kg seed germinate, then seed requirement is 100 kg. If 1 kg, 100 by 90 kg means you need more. You need to overestimate it. And then if 30 kg is required, then 30 into 100 by 90. Or you can straightway divide this 30 by zero point 0.9. So easy. Then it comes out to be 33.33 kg. Now, next is we need to go for adjustment of seedling survival. 80% is the seedling survival. That means the 20% seedlings have died. So we need to adjust for that one also. So if seedlings of 80 kg seeds survive, then seed requirement is 100 kg. If seedlings of 1 kg seed survive, then seed requirement is 100 by 80 kg. If seedlings of 33.33 kg survive, then seed requirement is 33.33 into 100 by 80. So you will get the seed quantity. So what important is that first you calculate the seed requirements at 100% germination and at 100% survival. And then you divide that value by the germination percentage and seedling survival. You multiply these two on the as denominator, zero point 0.9 into zero point 0.8, whatever it is, and get the values. So here seed rate comes out to be 41.66 kg required for 1 hectare. So you can see that initially it was 30 kg, but because of poor germination and poor seedling survival, we had to increase the seed rate, which is now 41.66 kg per hectare. So next is, I will show you this example also, similar kind of example. I will be a bit fast this time. So, or you can do it in practice. You need not to do it now. It will waste your time. Those who are interested can make a practice of this. I suggest you to make practice so that you are able to retain it forever. You cannot learn without doing it, learning by doing. That is why we need some practicals. Now, we go to the next part of this exercise, estimation of yield on the basis of yield attributes. You understand yield attributes, these are the grain yield contributing factors which make their contributions towards the grain yield. And in case of rice, or if I say rice, that means paddy, rough rice or coarse rice. So reported as rough rice at 14% moisture. Remember, the yields of rice or rough rice are reported at 14% moisture, except in a few countries. Okay, in some countries like Japan and Korea, it is reported as brown rice or sometimes polished rice. So in case of some countries, yield is reported as rough rice at 14% moisture. In some countries as brown rice. In many countries, it is reported as polished rice. So polished rice is actually milled rice or white rice, which is uh, produced after milling or after polishing. Then it is also called as white rice. So in India, the rice yield is reported as milled rice. However, Food and Agriculture Organization FAO always report grain yield as rough rice or coarse paddy. Now, conversion factor, you can remember this is the conversion factor. From brown rice, I think you must remember brown rice. I told you when you do hulling, you remove the external appendages of the rice seed. Then whatever is left inside is your brown rice, which is a true caryopsis. So that is your brown rice. So if you want to convert brown rice yield to rough rice, then you can multiply brown rice by 1.25. So brown rice into 1.25 is equal to rough rice because brown rice yield is 80% of the rough rice. Therefore, the factor 1.25. So if you want brown rice from rough rice, you divide rough rice by 1.25. You will get brown rice. Brown rice yield to rough rice. Now conversion factor of 1.5 is used when you want to convert milled rice yield to rough rice yield. Means milled rice into 1.5 is equal to rough rice. Milled rice into 1.5 is equal to rough rice. Or if you want milled rice, then rough rice divided by 1.5. So this kind of relationship you can develop, you can remember. Factors are 1.25 for brown to rough rice and 1.5 from milled rice to rough rice. And you can see the conversion, the brown rice is 80% and the milled rice is 66.7% of the rough rice or coarse paddy. Any clarification in this, Vasla?
Sir, could you please explain what is the composition of brown rice?
See, composition of brown rice, I already explained in one of the lectures, and I have told that brown rice is made up of two parts. Three bran layers are there, and it has got endosperm. So endosperm is mostly starch. It is starchy, and these aileron layers or these layers, or you can say these bran layers, they are rich in oil, contain 20% oil, and they also contain protein. They also contain vitamins, minerals. This is a rich part. So I will give you a composition of rice grain again at some stage of my presentation. Maybe next time I will give you. Okay. So now after
Yes, sir.
this, after knowing with this background, now let us know about harvest index and grain and star ratio. Harvest index, everybody knows, it is not new to you. Economic yield means grain yield divided by biological yield. So biological yield is your grain yield plus stover yield or straw yield. And then harvest index is equal to dry grain yield. So here dry grain yield does not mean that it is 100% dry, it has no moisture. So it is actually sun-dried grains. These are sun-dried grains, and then divided by total dry weight. And you can calculate this dry grain yield also if you multiply harvest index by total dry weight. So in this case, you can see that grain yield is basically decided by the harvest index. What is the value of harvest index? And the total dry weight is important. And among these two, harvest index has more weightage. So in this case, what I want to say here is that higher the harvest index, in general, higher will be the yield. Higher the total dry weight may not always reflect in higher grain yield. Because if the harvest index is poor, then despite higher total dry weight, farmer may get lesser grain yield. So therefore, harvest index is very, very important. And these days, if you remember, harvest index is going up to 50%. On an average, 45 to 50% harvest index is there. So if it is 50%, then that means the grain to star ratio will also be 1:1. The grain and star ratio will also be 1:1. So total dry weight of a good rice crop is 10 to 12 tons per hectare. So total dry weight means here it is biological yield. Biological yield. Depending upon the variety, some varieties yield more, management and environment. These factors will affect the biomass yield or biological yield, which is generally 10 to 20 tons per hectare. Harvest index is about zero point 0.3, say 30% for traditional tall varieties and 0.5% for improved yielding or short duration varieties. As a result, the grain yield may range from 3 to 10%. 3 in the traditional variety to the highest 10 tons per hectare in the high yielding varieties. The grain to star ratio, it is similar to the harvest index and extensively used in the past is the ratio of the dry grain yield to the dry straw weight. Means dry grain yield divided by dry straw weight. Suppose it is zero point 0.4. So zero point 0.4 divided by 1. So you can calculate the ratio. 0.4:1. Or you can do it narrow also. The grain star ratio of rice ranges from about zero point 0.5 to, in traditional variety, you may have just 0.5, but in high yielding varieties, it can be 1, means 50-50. So out of total biomass, 50 will be grain yield and 50 will be straw yield. This is a best case for wheat. In wheat, we are getting 48 to 50% of harvest index. Therefore, in wheat, half of the yield will be stover or store, half of the yield will be grain yield. Now, yield components in rice, you can see what are the major yield components. So, panicles per meter square is an yield component. Panicle length is a kind of yield attribute, but normally it is not used in calculations. It is not used in calculation. It indicates generally longer the panicle, you expect that the grain number will be more, but that does not always hold true. Then panicle weight is also an yield attribute, but it is not used for calculation of grain yield. For calculation of grain yield. Now, number of spikelets per panicle are important yield attribute, and these are used for calculation or estimation of grain yield. Number of spikelets per panicle. And then spikelet fertility is also important. That is filled grain. So there may be two kind of spikelets. I have shown you picture what is meant by spikelet. Spikelet is one kind of flowering structure which encloses your flower or floret is inside the lemma palea. You remember this whole structure makes up is a spikelet. I have shown you structure of the spikelet. So number of spikelet is very, very important. But many a times, some spikelets may remain unfilled and some can be filled. So the proportion of filled grains or filled spikelets is your fertility, and proportion of unfilled grains or sterile grains is your sterility. You can call it sterility percentage. So you can work out one and other can be calculated by subtraction methods. So spikelette fertility is important, and it is very important component of grain yield. Then 1,000 grain weight, of course, it has its own weight, and it contributes to the grain yield. Normally, if your grains are thin and their 1,000 grain weight is low, their yields will be lower compared to the grains which are thick, bold, and generally in that case you will get more yields. So these are the yield attributing components. Among all these, panicles per meter square have the largest weightage. Largest weightage is given to the panicles per meter square. Panicle number means your ear bearing or panicle bearing tillers. How many are there? And then number two important yield component is number of spikelets per panicle. Per panicle. And third one is spikelet fertility, and fourth one is 1,000 grain weight. So these are the four important yield attributing characters in rice. You need not to mention panicle length and panicle weight. These are used in some cases in breeding programs, this and that. Now see this picture. Are you able to see this picture, Dilshana? Dilshana? Hello? Uh, Subham?
Hello, yes, sir.
Okay,
Yes,
you
sir.
can listen. You can hear.
Yes, sir.
Okay, I think everybody is listening to me. I hope so. So now you see this picture. In this picture, the different yield components are shown, and their relative importance or their weightage is also shown here. So you can see grain yield is starting with the germination or sowing. After sowing, germination will be there. Then tilling will be there. So this tilling is very, very important. This tilling will finally decide the panicles per meter area. If tilling is low due to genotype or due to environmental conditions or due to soil conditions, if tilling is poor, less number of tillers per hill, then panicle per unit area will be less. So we need to have optimum number of tillers or good number of tillers so that we can get maximum panicles. If tillers are not there, how come we can get panicles? So first important thing is that we should have sufficient number of panicle. And what is that magic figure? Ideal figure, panicle number. So in most cases, it is 250 to 300 panicles per unit area will give you better yields compared to too many panicles and too less panicle. Too many panicle means your grain fertility will be affected, your size of the specklet will be affected. So we need to find out the optimum level of panicles per meter square. In Australia, they have their Australian rice check program. Australian rice check program, they have fixed that every 1 meter square area of rice should have this much number of tillers, and this much number of tillers will give us so many numbers of panicles. So they manipulate it. They manipulate it. So to optimize the yield. So therefore, here tilling is important to get more panicles per unit area. Then comes the reproductive stage, that is panicle formation stage. You can see panicle initiation up to the boot leaf stage. You can see, and here you can see this is the panicle formation. Panicle formation. So second important aspect that determines the yield of rice, and for that matter, it can be for wheat, for other crops also. So this panicle formation, initiation, development is very, very important. So if the development is poor, it will make less number of spikelets per panicle. If there is no proper water, proper moisture at this stage, the spikelet number will be less. If there is no nitrogen application at this stage, this is very critical stage for nitrogen application, for water application, and for temperature also. If there is some bad temperature, not optimum temperature at this stage, then the spikelet development will be adversely affected. So if your spikelets are not in optimum number, we need optimum number of spikelets, not too less, not too much. So in this case, the spikelet number is important. Second is spikelet size. If size is low, size is not optimum, very, very small, then we cannot expect a good flower, good flowering, and good seed setting in this. So therefore, the panicle development stage or panicle formation stage, it actually determines how many spikelets will be produced, spikelet per panicle. So therefore, this stage is very, very important. We need to understand. Next comes the flowering stage. At flowering stage, it will decide the fertility of the spikelet. The panicle formation decides the how many panicles, how many spikelets will be formed. But flowering stage will decide what will be the fertility. So here are also there should not be shortage of abiotic factors. There should not be any abiotic stress here because abiotic stress, for example, if it is temperature is too high or too low, I have discussed yesterday about low temperature damage in nursery also. So low temperature can harm rice at any other stage also. So low temperature can result in poor pollen grain shedding, pollen grain development, formation, pollen grain germination, and ultimately your spikelets will remain unfilled. If conditions are favorable, then you will get more spikelet filled per spikelet, oh sorry, per panicle. Otherwise, if conditions are unfavorable, then unfilled spikelet number will increase. The filling of spikelet, the fertility of the spikelet will be low. The last thing is at maturity stage, means from flowering to ripening. Flowering here suggests that fertilization has taken place. First, it was pollination, then fertilization. Immediately after fertilization, the seed development starts, and then grain filling happens. So during this period, the during flowering to ripening, it will decide the 1,000 grain weight. The weight of a single grain will be decided during this particular stage from flowering to ripening stage. So here also you need some photosynthesis, bright sunlight. Here, bright sunlight, light intensity, all are going to affect the grain filling. Bright and optimum light intensity at this stage means you will get more photosynthesis from the active leaves and then more contributions of carbohydrate in the development of grains. So therefore, at the time of maturity or ripening phase in rice, weather should not be cloudy. If we get cloudy weather, that means the light reaching the earth is less. So therefore, photosynthesis will be affected. And flag leaf makes immense contribution to the carbohydrates in this case. So therefore, weight of the single grain is decided by the at this phase or at this stage. So overall, you can see the last line, grain yield is equal to panicles per unit area into spikelet per panicle into fertility of spikelet into weight of single grain. So this is the formula to calculate the grain yield. And now, how to calculate? This is a numerical problem. I will be a bit fast. Calculate the number of hills and panicles per square meter, assuming plant spacing as 25 into 25 centimeter and number of panicles per hill as 20. So we discussed in the beginning, we need to know how much area is occupied by single hill or single plant at one place. So area per hill. So one hill will occupy because the spacing from row to row is 25 and plant to plant is 25. So 25 into 25 centimeter square is equal to 625 square centimeter or centimeter square. And it comes out to be, you can convert it by dividing with 10,000, you can convert to square meter. So if you divide it by 10,000, it is 0.0625 square meter. So much of area is required for one hill or one seedling, you can say. The number of hills per meter square, we discussed in the beginning. Area 1 meter square. 1 meter square means 1 meter into 1 meter divided by spacing. So spacing, you know, it is in meter square, 0.0625. So 1 divided by 0.0625, you get 16. This meter square can be cut by meter square. Therefore, you get whole number. That means 1 meter square will have 16 number of hills. So then you can work out for 1 hectare. 1 hectare. How we can work out for 1 hectare? Sumit? Sumit? Dada?
Yes, sir.
How
Yes,
can
sir.
we work out? If we know in 1 meter square, we have 16 hills, then in 1 hectare, how many hills will be there?
Then in say we have to multiply with 10,000 per square.
So what will be the answer?
16,000. 16,000.
नहीं यार,
16,000.
दोबारा कर. 16 के आगे 4
1
जीरो
meter square
लगेगा
में
ना.
16.
16 के आगे 4 जीरो लगा के बोलो. प्लीज स्पीक.
हाँ 16 के 16 1,60,000.
Correct. 1,60,000. So this is simple calculation. So number of panicles per hill into number of hills per square meter. Now we are dealing with the number of hills there. Number of panicles per hill into number of hills per square meter. So in our problem, you can see that one hill will produce 20 panicles. One hill will produce 20 panicles. So then how many panicles will be there in 1 meter square? Is it okay? How many panicles will be there in 1 meter square? So number of panicles per square meter is equal to, see the green line, number of panicles per square meter is equal to number of panicles per hill into number of hills per square meter. So number of panicle per hill is given to us 20, and we know number of hills per square meter are 16. So therefore 320 is the number of panicle per square meter. Similarly, this 320 can be converted into hectare also. In 1 hectare, how many uh, panicles will be there? Simply by multiplying it by 10,000. If number of panicles, suppose this is just one example, one message to you. If number of panicles per square meter is less than 250, something is wrong. Means it is too low. Number of panicle is too small. The yield will be low. So we need to check whether the method of farming was wrong, variety was wrong, or there was some problem with the soil. And we also need to check spacing. Was it optimum or was it not optimum? And have we applied proper fertilizer doses or not? So all these management aspect varieties are to be checked if you are getting less than 250 panicles per meter square. So at least we should have more than that. Every stage of growth contributes to grain yield. In the last case, you have seen that every stage, tilling is contributing, panicle formation is contributing, flowering is contributing, and the maturity is also contributing towards the grain yield. All these stages or phases are contributing to the grain yield. Good management is necessary at all stages. Environmental factors affect every stage. So in the last case, we have seen here also, we need to have good management so that we can have more tillers and more panicles. So proper nitrogen management is important. Other nutrients are also important, but nitrogen management is very, very important as nitrogen is the master which can increase the tilling, but that drives the demand for other nutrients also. So here, message is that we should have balanced fertilization so that we can have maximum number of tillers or optimum tillers and optimum panning. Spikelet number is influenced by water, moisture, soil. I discussed all these issues. So environmental factors affect every stage. Now, a second method for examining yield performance is to break the yield into its components. So this is a formula, a state-way formula to calculate the grain yield. You must remember this formula. I will ask some numericals in your theory exam about the grain yield, calculation of grain yield from this formula. And from this formula is very simple. If you do not know grain yield, and other parameters are given, so you can work out the grain yield. If grain yield is given to you and number of panicle number per meter square is not given and other parameters are given to you, you can easily calculate panicle number per meter square. If spikelet number per panicle is not given to you, but other parameters are given, grain yield is also given, then you can easily work out the spikelet number per panicle. So this is called as reverse calculation. I can call it reverse calculation. State calculation is grain yield is equal to panicle number per meter square into spikelet number per panicle into percentage field spikelet into 1000 grain weight and into 10 to the power minus 7. You can remember this formula. So how this 10 to the power minus 7 has come? It is just to neutralize the units. Some units are in panicle number per meter square. Some are in per panicle, some are in percentage, some are in grams. Because the grain yield is given in tons per hectare. So if you want to convert all these parameters into tons per hectare, then you need to multiply it by 10 to the power minus 7. You can do yourself also, try to understand how this 10 to the power minus 7 has come. So first two parameters like panicle number per meter square and spikelet number per panicle can be multiplied with each other. They can be multiplied with each other and they will give us spikelet number per meter square. They will give us spikelet number per meter square. So we'll go to the last link. We'll go to the last link and I will stop share here. And in last link, I will try to finish everything for today. So this formula is really very, very easy to remember. You can work out the spikelet number per meter square, fertility percentage, 1000 grain weight, and into 10 to the power minus 7. Then I'm giving you some examples later. So there is some confusion in the terminology of yield components. The following are considered synonymous or synonyms when yield components are discussed. For example, if I say spikelet number per panicle, I can also say grain number per panicle because one spikelet will give us one grain, whether that grain is filled or unfilled, but it will be counted as grain. Total spikelet number per meter square will be total grain number per meter square, whether it is filled or unfilled. You can say percentage filled spikelets, and you can also say percentage filled grains. They have the same meaning. So whatever is written in equal to, you can use them alternatively. For example, total spikelet number per meter square, I can say total grain number per meter square. So therefore, to make a distinction in filled and unfilled, I need to say total filled grain number per meter square, total unfilled grain number per meter square. Now, this is a numerical from the following values of yield components. Compute grain yield of rice in tons per hectare. Number of panicles per meter square are 375. So it is given to us. Spikelet number per panicle is given to us, that is 100. Filled spikelet percentage is 85 and 1000 grain weight is 29. So these four parameters are given and fifth one is to be calculated, that is grain yield. So you remember you can multiply all these and then multiply by 10 to the power minus 7. You will get the answer in grain yield tons per hectare. So I think you can do it. It's simple.
Yes, sir, 9.243 ton.
iPay, can you do it? 375 into 100 into 85 into 29 and into 10 to the power minus 7. You will get the yield in tons per hectare. And if you have done, that is really good. Okay, so this is your home exercise. You can do it. Simply in this you need to put them. Spikelet number, or you can straightway use the first one also. Panicle number per meter square into spikelet into fill into 1000 into 10 to the power minus 7. So these two exercises you can practice yourself. Now this is the answer. You can check. Those who have done can check their answer if it is correct. From the same data, these were two examples, 375, 185, 25, and this. So here you can see, or whatever is there. Just you now concentrate on this table, the data. First column tells us component, yield component. Wet season is normally rainy season. Dry season is non-rainy season. It may be, in our case, suppose it is Rabi season. So number of panicles in the first case was 250. In dry season, suppose it was 375. This is there. Spikelet number per panicle, it is equal in both the cases. 100 here, 100 here. So therefore, the total number of spikelet per meter square will be 250 multiplied by 100. So you get 25,000. 375 multiplied by 100, you get 37,500. Then filled spikelet percentage. So in this case, it is 85 for both. It is given 85 here, 85 here. And then 1000 grain weight in gram is equal in both, 29, 29. Expected grain yield. So you can multiply all these, or you can say the last three. Total is spikelet per meter square into filled spikelet and into 1000 grain weight. So you will get the grain yield in tons per hectare, 6.16. Similarly, here you get 9.24. So now here, what message this slide is giving to us? So the message is that you see spikelet number is same, filled spikelet is same, 1000 grain weight is same, but the panicle number is different. So one is having about 125 extra panicle number per meter square, which is going to make a huge difference. Just by increasing 125 panicles, you could increase 3 tons of yield. So from 6.16, it has increased to 9.24. So here or anywhere also, the maximum contribution in grain yield of rice comes from panicle number per meter square. Now, this is a numerical where yield is given. The target yield is given, and you need to calculate the panicle number per square meter. This is a numerical where the target is 4 tons per hectare yield. You want to achieve 4 ton per hectare yield, and all the parameters are given. Yield is given. Your spikelet per panicle is given. Percentage filled spikelet is given. Weight of a single grain is given. All the other attributes are given, but panicle per square meter is not given. So you need to calculate this. So you can see here, A student can always remember any dry matter, any grain yield, any data in weight. If you take from 1 square meter, 1 square meter, and the unit is in gram per meter square. Say grain yield in gram per meter square, dry matter in gram per meter square, biomass in gram per meter square. So it is equal to tons per hectare. If I say 400 uh, 400 grams, uh, I need to reconsider it. There is some problem in this. Kilogram per square meter. If it is kilogram per square meter, then it is equal to tons per hectare. Tons per hectare. So here target yield is 4 tons per hectare, and we can convert it into per square meter. So if you convert this 4 ton per hectare, so it comes out to be 400 gram per square meter. Characteristics of the variety are number of panicles per hill. In one hill, you will get 14 uh, panicles in one hill. Spikelet per panicle is 100. Percent of field spikelet 83.3%. Weight of a single grain is 0.025. Or you can say 25 gram is the 1000 seed weight. Use this formula to determine the number of panicles per square meter needed to achieve the target yield of 4 ton per hectare. So yield in grams per square meter, this is the formula, is equal to panicles per square meter into spikelets per panicle into percentage field spikelet into weight of a single grain in grams. So here you can put 400 gram is equal to panicles per square meter, because we are given in for number of panicles are given for one hill, which is 14. 100 gram is equal to panicles per square meter into 100 into 83 point. You just place these values and you get uh, 400 divided. If you do the calculation of this, you can simply do the calculation. 83.3 divided by 100, you get 0.833. So 400 divided by 100 into 0.833 into 0.025, it is 192. So 192 is the panicles per square meter, because here spacing is not given, and this number of panicles per hill uh, is given to us. So from this, we will use this. So if the spacing used was 25 into 25 centimeter or 16 hills per square meter, 192 panicles per square meter, there are 16 hills. You know, in 25 by 25 centimeter, you will have 16 hills per square meter. So therefore, 12 panicles per hill. 12 panicles per hill, you can achieve 400 grams or 4 tons per hectare yield. The variety used can produce more than 12 panicles per hill at uh, the variety used can produce more than 12 panicles per hill at 25 into 25 centimeter spacing. Target yield could be obtained if the actual yield was below 400. Anyways, so I hope you are successful in doing this numerical, and this can be applicable to other parameters also. The only thing is that you need to practice it yourself so that you develop mastery. If you come across any problem, you can come to me or you can discuss with me on email. If you have any problem, any question up to now, you can discuss with me. Any issue you want to discuss, your questions, queries are welcome. IP?
Yes, sir.
Yes, please
Hello?
ask.
Yes, sir.
Yes, please ask.
Sir, no questions, sir.
No problem. So now we go to the last part. and which is called as grain yield efficiency index. So it can be calculated to classify genotypes for their nitrogen use efficiency as follows. So it was basically developed by Fageria. As one time I have told you, this scientist is from Brazil, Dr. Fageria, in 1988. He developed this index, grain yield efficiency index. And if you know, we have got All India Coordinated Rice Improvement Project. You must be knowing about All India Coordinated Projects of ICAR. So ICAR has All India Coordinated Project for major commodities, like for All India Coordinated Research Project on wheat, it is in Karnal; on mustard, it is in Bharatpur; on fodder crops, it is in Jhansi; on rice, it is in Hyderabad. Indian Institute of Rice Research is there in Hyderabad, which has this coordinated center of the project. For tobacco, you will find in Rajamundry. Similarly, for cashew nut, you will find in Kerala. So depending upon the crops, we have these centers in ICR institutes and also in some state agricultural universities. These projects or schemes are running. So some of the project for improvement means for plant breeding are basically useful for development of varieties. I'm telling you the case of rice. If you want to get your variety released, you need to send a proposal in a set format to the Indian Institute of Rice Research, where you have All India Coordinated Rice Improvement Project Unit. One unit is there, which is directly funded by ICR, and that unit funds different centers in the country. So they are doing coordinated trials of varieties, and evaluating those varieties under different nutrient levels. Just few years back, you may not be knowing that whenever new varieties are released, their field evaluation is done, and their field evaluation was being done under the background of nitrogen. Are your variety responsive to nitrogen? Yes or not? So those varieties were actually or basically evaluated against the nitrogen. If these varieties or some varieties are nitrogen use efficient, then they will be easily released compared to other varieties. But after some years, now they have developed another concept that your variety should be efficient for NPK. NPK use efficient. All the three nutrients should be utilized by varieties effectively. Then your varieties will be released. So most varieties or common varieties are released under the background of this for high yield and quality. But for you see disease resistance, insect pest disease tolerance, you have another criteria. So there are some breeding objectives. Are you breeding for high grain quality or insect pest or disease tolerance, resistance, this and that? So here message is I want to tell you is that grain yield efficiency index is used comprehensively or very widely by All India Coordinated Research Improvement Project on Rice to find out or to evaluate the rice varieties. So what they are doing, at one place, they will give allowed 10 or 12 genotypes, 10 or 20 genotypes, maybe sometimes 20 genotypes. They are evaluated under graded, graded levels of nitrogen, say 0 kgn, 40 kgn, 80 kgn, 120 kgn, or 160 kgn. So nitrogen may be there, kg per hectare. And in this background, simple trials are conducted, nitrogen into variety trials. So nitrogen is always kept in main plots and varieties are kept in subplots. So in this case, you will get the two-way table data on nitrogen rates and genotypes. Two-way table, and then analysis is done Main effects are partitioned into genotype effect, into main plot, subplot, and their interactions. So this is how data is recorded. And then you will get every variety. Every variety, suppose you have, just try to understand. Suppose you have 10 variety, V1, V2, V3, V4, V10. Similarly, you have 4 nitrogen levels. 4 nitrogen levels, 0, N1, N2, N3. 0 could be 0, N1 could be 40, 40, 80, 120. Just assume it. So the lowest nitrogen level is not 0 here. It will be considered as 40. And highest nitrogen level, 40, 80, 120 is 120. Lowest is, of course, in other sense, it is 0, but level of nitrogen application, lowest level of nitrogen application is 40 here. 0, 40, 80, 120. 120 is highest. So these 4 levels, combination of 10 varieties and 4 levels will be there. Will be there. So with this data of or two-way data, we can work out or we can calculate the grain yield efficiency index. I'll show you how it can be calculated. Now you see the formula. Grain yield efficiency index is equal to grain yield of a genotype. GN means genotype at low nitrogen level. Means, as I told you, suppose you want to, there are 10 genotype, V1, V2, V3. Suppose you want to calculate the use efficiency of V1, grain yield efficiency index of V1, variety 1. So you can say grain yield of a genotype means grain yield of V1 at low nitrogen level. At low nitrogen level means that is at 40 kg. Similarly, average grain yield of all genotypes at low nitrogen level. So you can take the average of all the 10 genotypes yield at low nitrogen level at 60 kg, at 40 kgn per hectare. So you can take average of 10 data. 10 data will be there at 40 kgn into grain yield of a genotype, GN means genotype, at high nitrogen level. Means for V1, you need to take the same variety. So here you need to take V1, grain yield of V1 at high nitrogen level or at 120 kg N per hectare. And then again, average grain yield of all genotypes at high nitrogen levels or at 120 kg N level. Here also, 10 different varieties will be evaluated at 120 also, at 40 also. So respective data are put here. You can do the calculations and you will find value either less 1, more than 1 or less than 1. Then you can find out the genotypes which are nutrient use efficient or nitrogen use efficient in this way. Here you can see the genotypes having grain yield efficiency index values of more than 1, they are considered as capital E, efficient nitrogen user. If it is 0.5 to 1, then moderately efficient N user, means up to 1, up to 1. Moderately efficient N user, ME. If it is less than 0.5, inefficient N user. So normally what happens? A genotype which is performing good both at high level as well as low level. Generally, a genotype which is performing better at both high and low N level will be nitrogen use efficient. In addition to this, I want to put two more points. In general sense, people consider that the genotype which performs best at the lowest level of nitrogen will be the most nitrogen use efficient. But that is not the case actually, because we want more and more yields. We want more and more yield. So that particular genotype, if it also gives more yield at high N level, because we want to increase the yields high N level also, then that will be the more nitrogen use efficient. So it depends how you interpret the results. So this is one example to show you. You can see this example. These are the different genotypes of rice, basmati genotypes. Number one is Taravadi basmati, PB Pusa Basmati 1121, Pusa Sugand 5, and these are some entries. So there are 1, 2, 3, 4, 5, 6, 7, 8 entries are there, or varieties are there. V1, V2, V3 like that. And on y-axis you have yield. And these were worked out. These were worked out. So you can see this Taraudi Basmati, it was found to have the lowest value of grain yield efficiency index, 0.68, and then 0.87 PB 1121, so on. So this is how we can find out. So we can see these are inefficient. This is moderately efficient, you can see, or more than one means they are efficient. So these two varieties are very tall. Pusa Basmati is the, oh, sorry, Taravadi Basmati. You can remember this name, Taravadi Basmati. Taravadi is a place in Haryana, Taravadi, where Basmati has very high diversity kind of things. And this variety was developed from there. And it has the best quality Basmati, Taravadi Basmati. If you eat it one time, you will like to eat it again and again. And then Pusa Basmati 1121, it is a historical variety in India. And I'll discuss in detail about this variety. So you can see this grain yield efficiency index is also good. So it ends this lecture here. If you have uh, questions or suggestions or point of view, you can discuss here. So now you can open your videos. Shubham, अब तो खोल लो वीडियो भाई. अब तो it is going to be end of the lecture. Those who can do it, we can talk to each other. And if you have any doubt, any question, you can ask me related to this practical. So any question you have? Anand? No
No,
question?
sir.
Then you
No
can have
question,
your
sir.
nice lunch. So we tomorrow, do you have any class of cereal crops, soil fertility, or any other?
सर 501 की है 501 की
501 किस टाइम है?
शायद सर 11 से 12 है
ठीक है, आई विल टेक दैट क्लास. और मुझे यार टाइम टेबल भेज देना किसी पे हो तो, व्हाट्सएप कर देना टाइम टेबल 3 कोर्स का.
ठीक
बार
ठीक
बार
ठीक
दिक्कत होती है पूछ. ओके, थैंक यू वेरी मच, हैव ए नाइस टाइम. थैंक यू.
कल सर कल सर ऑफलाइन होगी क्लास
आई विल टेक योर क्लास टुमारो.
ओके
सर
सर
फाउंडेशन
तो
डे.
मैं तीनों कोर्स की क्लासेस करता जाऊंगा जब तक ये मतलब कोई इमरजेंसी नहीं आएगा. आई टेक ऑल क्लासेस. अब टेंशन लेने की जरूरत नहीं है, मैं जल्दी से जल्दी पूरा कर दूंगा. ठीक
सर
है.
कल ऑफलाइन क्लास होगी सर.
कल क्या होगा?
कल फाउंडेशन डे आई थिंक छुट्टी होती है या फिर क्लास होगी.
भाई अगर फाउंडेशन डे होगा तो मैं क्लास नहीं लूंगा, क्योंकि दिस इज
नहीं सर
ऑर्डर बाय द
ऑफलाइन नहीं लीजिए
है.
ऑनलाइन
अगर आप लेना
ऑनलाइन
चाहोगे
लिखा
हो
नहीं सर
जाएगी तो हो
और
जाएगा
नहीं,
सर, कोई इशू
ऑनलाइन
नहीं.
तो पढ़ाया जाएगा, लेकिन भाई आई विल नॉट टीच यू ड्यूरिंग द दैट पीरियड. During the period of foundation day, teaching will not be there. So we will decide. So
सर
actually we need
अगर
to
क्लास पॉसिबल है
है.
डिवीजन में तो आप ले सकते हो, अगर अगर नहीं तो फिर ऑनलाइन ले लीजिए आप.
नहीं, डिवीजन वैसे तो बैठ के अच्छा लगता है क्लास लेना, लेकिन ये है कि आज तो छुट्टी थी इसलिए दिक्कत हो गई. तो हम जो है वो कल अगर 11 बजे नहीं हो पाती है, मोस्ट प्रोबली आफ्टरनून में होता था ये फंक्शन. और अगर ये फोरनून में फंक्शन हुआ तो ठीक है, कल की कैंसिल हो जाएगी, फिर देखेंगे फिर क्या होगा. आफ्टरनून में आई विल सी द पॉसिबिलिटी आफ्टरनून. और कल तो फिर आपका 10 से 11 भी खाली होगा,
यस सर
है. तो अगर मान लो इफ
यस
देर इज नो फाउंडेशन डे celebration in the forenoon, I'll take your classes from 10 to 12:15. ठीक है. बड़ी मायूसी सी आ रही है यार, क्या हो गया भाई ऋतिक? क्यों टेंशन क्यों ले रहे हो यार? क्लास को तो एंजॉय किया करो, काहे की टेंशन लेते हो? शुभम, टेंशन मत लिया करो।
Yes, sir. Yes.
ओके, थैंक यू वेरी मच। आई विल इन्फॉर्म यू बाय दिस इवनिंग। ओके।
सर ये पीपीटी सर शेयर कर दीजिएगा आज ही, न्यूमेरिकल वगैरह हो जाए।
चल, मैं आज तो नहीं, कल कर पाऊंगा क्योंकि अब ऑफिस जाना पड़ेगा। इससे पेन ड्राइव से मैंने हटा दिया, लेकिन ये एटलीस्ट ये वाली मैं भेज दूंगा आपको। तो अभी की
हाँ
है,
सर।
अभी भेज दूंगा। इसके अलावा बाकी न्यूमेरिकल्स आपके बहुत बचे हैं अभी। सीड जर्मिनेशन, इमरजेंस का बचा है, काउंटिंग का बचा है, मॉइस्चर डिटर्मिनेशन, मॉइस्चर परसेंटेज। और एक चीज आप सीख के आना, मॉइस्चर श्रिंक इन ग्रेन, उसको सीखना। MOISTURE, मॉइस्चर श्रिंक। ठीक है, इसको देखना, इसका बहुत वैल्यू है बिजनेस वगैरह में। जब हम गेहूं धान बेचते हैं तो मॉइस्चर श्रिंक ऐसे चाह रहे हैं। ओके, थैंक यू, बाय।
ओके सर, थैंक यू सर।
थैंक यू।